for these. Alrighty, so today is a little review session, and I'll be creating a brand new Swift file. So I'll just call that maybe matrix UI something. All right. Okay, and firstly, it is going to be import UI kit, and then declare a class. So this class is, I think I'm going to call that matrix UI VC. All right. Okay. Very straightforward here. All right. And then UI view controller, right? And then view to load. All right. And then something like that. Super peer review to load. And definitely, all right. Um, if you call or if you set these method, this view controller to be the root. So for instance, the matrix, VC, right? Um, and logically speaking, all right, it gives you a blank or simply just a black view scene or a screen. It is simply because we didn't initialize anything. All right. And you will be seeing that real quick here. All right. Okay. So in the meanwhile, you can create maybe you can call that a main VC um tool or something here, right? Okay. That is going to be a UI view controller. Okay. Or you can call that maybe main VC super, all right, super main VC or something that you can keep using it later. All right, I'll be showing you that real quick here. Uh, or you can simply call that root, okay? A root VC. All right, okay. So for that, you can declare a override func, override func, and this is a view load as well, and a super.view load here. And you can manually change the background color into maybe a system yellow, right? Good. Okay. So now what you can do for this trick is you can cast it the matrix UI VC by root VC right here. All right. So and then as you can see, matrix UI VC inherits everything from the root VC. So now if I run the code again, so I didn't change the scene delegate, right? It's still a matrix UIVC. However, the background color will be automatically updated by system yellow. Let it run a little bit. It is because this class is, all right, so now matrix UIVC is a subclass of root VC now, right? And it inherit, inherit, inherits all properties or features. I'll just use the features from root VC. So how do you understand that? It's like you basically you inherit most of the property characteristics from your parents, right? Because well, yeah, right? Okay. So therefore, consider this is a child of root VC, right? So it inherits everything from the root VC here. And then you can also create another class. For instance, this is like a matrix underscore UI VC underscore one. You can also cast it as root VC again. And you don't have to basically have the override func is right. You don't have to because it has a override func here. And then if you run the code again, the root view controller still be these, right? And it inherits every basic fundamental stuff from the root VC here. And I can tell Mark used this before, and he keeps using this till now. the backyard map, right? Okay. And later on, yes, Mark will be in the Zoom and yes, okay. So literally speaking, I basically I am teaching everything to you exactly the way I taught or teach Mark, right? Okay, there we go. Good. However, you for some reason you do need these. It is simply because you need to call some method here, right? Okay. And then right here you can also create a 2D array. So let a matrix to be. This is the way to declare a 2D array or matrix. I'll just call that matrix one because there could be more than that, right? And then this is the way to declare it. So for instance, 0, 0, 0, and this is 0, 0, 0, 1, 0, and this is 0. This is 0, 0, 0. And logically speaking, all right, simply by checking it, it is a 3 by 3 matrix, right? It's a 3 by 3 matrix, all right? And you have to use the cast, data casting right here, right? Okay, to declare this. And then you can simply just use it, right, in another class. Why? It is simply because during the compilation time, right? This is a compiler. This is a compiler. The compiler allows you to access the root or the parent class to get this data, right? Therefore, you can access it free, right? You can access it for free, right? Okay, there we go. And if you run the code again, it will print the data for you for free. Why we want to do that is because if you create a game or like a visual detection or any app, a specific very functional app, there are lots of repeating stuff, right? Like something very identical, like an eye tracker, right, and a game, right? So, um, right. So you can simply create a root VC or a parent VC and then use other view controller to inherit its property rates. So it can be pretty straightforward. It can be just very convenient, very convenient. Okay. And this is also a concept or a principle. This is one principles of OOP, which is what? Which is um, inheritance. It's inheritance. So OOP has a four principles. Four principles. All right. Okay. And now we have these. So what if you want to display what if we want to display these on the screen, right? Uh, Simply just do that. It doesn't make too much sense. It is simply because right here is in the console. What if we want to show the data on the screen? So for that, we need to create a method. So this is maybe show UI or load UI, right? Okay. So we usually load the data first and then load UI later. But however, we do have these, so therefore we simply just load the UI here. And then we need to use for loop, right? And we have to use double loops, right? Because it's a 2D array. There we go. So therefore, I think I'll keep that. Oops. All right. So 2D array. So 2D array or matrix requires at least requires I would say yeah. Sometimes you can use a single. No, it has. You can use one loop, but well, it doesn't. Yeah, you can definitely use, but I mean usually it's a double loops, right? Okay, requires iteration to traverse, right? To traverse. So for I in in 0 2 dots less than, and then you can directly access this, but it has to be, you need to access the very first row and then do the count, right? Okay. So firstly is do the number of rows, right? And then for J in 0 2 dots less than matrix 1, now you need to access every column, right? And then count. Okay. So logically speaking, this is what? So firstly, all right, firstly traverse the row, and then you do what? And then you traverse the column, right? The column, the columns. All right. Well, since this is a 3 by 3, which is a square, so logically speaking, if you do not use these, it's still working. But in the real world scope, it can be n by m, right? N by m matrix. So then you have to use this, right? Okay. And then right here, we need to create as like a pixel or like maybe item or maybe just well, maybe just call it a box. So the box can be a UI button here, right? And then you can set the frame to be a CG rect. And then you want to design X and Y coordinate here, right? So for instance, for these, I guess we also need to declare let X to be a CG float and then do something, and let Y to be a CG float and equals to something here. Be aware. So the inner loop handles the column, right? Like dot, 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 dot. So logically speaking, we need to iterate X coordinate right here, right? So firstly, we need to cast the I into CG float because I itself, it is integer, right? So then we have that, and then multiply by the size you want it to be. So usually we can pass the size width right here. So this is CG float, and we just times W. And we can also declare where you want it to be at, right? So then we will just uh, this one is going to be, uh, I would just say maybe X margin or something here, right? I would maybe, I'll just put this like plus something here, maybe 10, all right? For Y, it has to be from, oh no, this one is actually J, right? J, the J. And for this is going to be I, right? And then it also multiplied by the width itself, right? Can also be plus 10. So if you watch this closely, right, so it looks like a fx equals ax plus b, right? Exactly, this is a linear equation, right? Linear equation, all right? Okay, a linear equation. And this is just basically, um, yeah, T math is still working, right? And then we put x and a y here, and the width is w, and this is w, right? Okay, so we simply just do that. It's a very effective way to handle the work, right? And then later on, so we can create a view period, add a subview, and we're adding the matrix. We're adding that box actually. So, and then box period background color. So we can assign a color. Maybe this one is, I would just use maybe black, right? And you can also declare the color, right? The color, blah, blah, right? Okay. All right. CG flows. Message here. I guess it's marked here. We'll be real quick here. Yeah. Well, Mark will be in CMU real quick. So this time period is very valuable for you, Alex, because I mean, usually you can learn much more, a lot um from Mark. Yes. Okay, so right now I need to call this method here. So load UI, and with the W, I will just put a 40 and run the code one more time. And then you'll be seeing lots of you'll be seeing a square. You'll be seeing a square here. And right, okay. So another I can modify is initial location. So for instance, 200, and then it will be pressed down, right? And then from here, I can do a little bit algorithms here, right? So then if something and then something. So I bet you probably know what I'm going to do here, right? So and right here, okay. So if matrix, yes, I'm accessing every single elements here. is equivalent to 0. I want it to be black. Um, maybe 1. All right. Matrix 1. All right. And else, that means other than 1, right? So I want that to be white. So then it looks like I have a black surrounding, and then I have a white inside here, right? Okay. So they're no, the opposite. Yes, this one. Oh, yeah, this one. Oh, I'll just do that. Yes. Okay. All right. So therefore, you can 100% control the flow and then control what it looks like, right? And if you want to add a little padding, so you can times 1.08. And of course, you need to do exactly the same to the y coordinate here, right? Okay. So there we go. And run the code one more time. And you can also create a parameters here, like you can call that maybe uh, padding, right? So the padding can be a CG float as well. So later on, you can just manage this value by simply just call this, right? Um, right, padding, right? And then for these, you can just simply 1.08 here, right? Okay. Or simply you can just call it a P rate because I mean we want to make the program as simple as possible, right? So therefore we manage the control flow here. Uh, so this is basically the beginning, the inspiration of visual detection, because if you're able to break down all the pixels here, right, then you can analyze the picture, right? So like a classification. It's simply because the picture you are seeing right now is lots of pixels, right? So lots of pixels. If you get closer to your screen, you can see dots, right? Like square dots. So therefore, in order to better understanding the vision, visual detection, so this is one of the best way to start with, right? Okay, and then you can also modify the control flow freely, right? Okay, so all by these. So later I will handle this over to Mark, and Mark will be walking you through. So basically today, what I want you to do is remember the icon eyes, right? The Comic Con. Do you remember, Alex?
Yeah.
So basically, today I want you to create to basically convert that picture into a pixel by using binary 2D array matrix. So therefore, then you can actually move the eyeballs, right? And then so therefore, it can be a pretty interesting and fun work, right? Okay, so let me share my screen one more time. So wait a second. I guess this is it, right? Yes. All right, today is July 31st. There we go. And this is the code right here. And then bigger. I'll just take a screenshot over here and place it here, right? Okay. So as you can see, whenever you manage the control flow, you control the system, right? You control, and then you can just make it more complex, right? There we go. Good. Okay. Let's see. Hello, Alex. Does this make sense to you?
Yeah.
Okay. So can you upload the eye picture as the um at where? At the Google Docs real quick. So therefore later on
Okay.
Mark will be, yes.
Okay.
Good. All right, hello Mark, how are you doing?
Good.
All right, so today I want you to go over a matrix with Alex here, right? So this is the sample code. The code is already in the Google Docs, right? Okay, so Mark, you can download this as a starter kit, all right? So therefore you don't have to build that. But I really wanted you to maybe uh go over this with Alex again. All right. Okay, it's in the Google Docs. So and this will also benefit everyone's understanding of 2D arrays for sure, right? Okay. So this is the way to declare a 2D array or a matrix here, 3 by 3. This is a root VC, and the matrix UI VC inherits from roots VC here. And then this is load functions, and then simply will render uh, the UI to this, right? Okay. Yeah, overall, Mark, does this make sense to you?
Yeah, I mean, just set up the squares, right?
Yeah. So this is pretty familiar to you, right? Do you have any questions?
This one should be fine.
Should be fine. Okay, so, what I want you to do today is, Alex, did you update the picture yet?
No, I'm finding it. Yeah.
All right. There. I got this. All right, Mark. So basically, all right, today what I want you to do is maybe create a UI just like this eye, but I want this to be like a pixel artwork. So simply using a 2D array to to display this, something like that. Makes sense, right? Okay.
Wait,
And
like, do you want me to replicate the whole thing?
the comic is done, and CON, this is done. So today simply just do this. Well, um, because Alex is doing a eye tracking system, right? So we want to make this a program as as fun as possible. And so therefore, eventually this eye can be like interactive. So therefore, whenever user click on it, so it can also do some reaction, right? So it's like a real like sentinel, right? To check the stuff. So instead of simply just these emoji, we want something like more, it's more AI stuff, right? So this one can actually give people some feedback, like, right, makes sense. This is one of these. Let's see that. This is one task, and we still have like next week, right? So we have plenty of time to work on this. And Mark, do you remember last times? I guess we finished this already, right?
Which one?
This page.
I can't see your page, your screen share.
Am I sharing? Oh, wait a second. I think, oh, why it stops? That's good. Ah, Jesus. Can Am I sharing my screen,
Yeah,
everyone?
this page is done. Yeah, basically it's done.
Oh, okay. I thought I was sharing my screen. All right. So this is the things here, right? So, Mark, can you see it?
Yeah.
Okay, great. So basically, Alex have done all of these letters. Okay. For these, currently he's using a picture, but eventually I want this one to be a pixel art. Therefore, a user can easily to click on and then have some reaction. So this can be a 2D array implementations here, right? So for instance, I think for this grayish area, we can use maybe a triangle algorithm, right, to create this. And this, well, I guess maybe we just create a simple eye without this too much details here. It just like create a pixel art. So yeah, let me do this here. So using 2D array matrix to create an interactive eye by UI button. Well, since UI button is interactive, right? Okay. And using 0, 1, and the other integer to build the matrix, and then use UI to render it, right? So for instance, right here, this is the sample code here. So for instance, we can define 0 is black, 1 is white, 2 is maybe gray. So then we can create eyeballs here and make each make each pick interactive by assigning uh assigning add target something here. All right. Okay. Does this make sense to everyone?
How detailed do you want the eye to be?
The eye can be, I guess, oh, like this. Okay. So if user tap right okay, so right direction to the eyeball, the eyeball will go right. It is like if I tap right here, eyeball will move to the right, but would not go beyond the iframe, right? Okay. And vice versa. Does this make sense?
Oh no, I was talking about the shape because you wanted to build this pixel by pixel, right?
Yes.
So like if I wanted to be that curved with pixels, isn't that like a couple hundred pixels? Couple
Uh,
hundred buttons.
I guess right now we don't have to make this a curve, so I think we can use the very basic uh like very zigzag. So I guess probably is by maybe 15. I guess it's probably 15 by 15 is the row. Column is probably 30. So then we can manage it. So yes.
So just a rectangle.
Yeah, just a rectangle. It's like a little, just a zigzag. So we don't have to make it like this very curved smooth. Yes. Make sense?
I think so.
All right, good. Okay, so I'll hand over this to you and okay, now Mark, please share your screen and then let's work on it. Good.
It's disabled.
Oh, there we go.
So from earlier. Give me a second. So we want to make a 15 by 30 rectangle first, I guess. So I guess start from scratch. Okay, yeah, first I guess we'll define like the sorry. We need to find the border. So I guess give me a second. I guess for Alex's, the original method is we just define every coordinate. But ours will take a while, so we could do it with a function, I guess. Storage for the numbers. So just create an empty array that we can add to later. So for here, we'll do a for loop. Do 15. So for in each iteration, we need a second one to do the columns. But since it's 50-30, we could also just use one for loop. So this is better practice, I think. Do you know how to do for loops? The syntax for Swift?
I think so, yeah.
And then so in here, okay. I guess let's start here. We're gonna create like each row, so they're gonna look like that. And so var and so we have an empty row here, and in this row we need to add in all of its values. But I got it backwards. J should be the column. I should be the row. So we want to build horizontally like that. So first we create that column. So it would look like want to go row by row. So when we start J, there's going to be 30 wait 15 by 30 was, yeah, this should be 15 long. I should go 15 this way. Do I have it backwards? I think the long way should be 30. Sorry, I'm talking to myself. If the long way is 30, then each row should be 30. That means, yeah, then we had it right the first place. Well, we'll just wing it. Anyways, we create an empty container for each row, and then we're gonna build in the amount of things we need there. So for 30 times, we'll just append. I guess in here we can do if conditions. So if it's the very top row, that means it should be the border. So we'll do if I equals 0. Then I guess we can append we'll append 1. But we can also check for other conditions, like if it's on the left side, that means the index should be 0 as well for j. So if j is also equal to 0, or if I is the very last row, so if I is equal to 15, and the last condition is if it's on the very right side, so if j equals 29, because we go from 0 to 29 and 0 to 14 because this is exclusive. And then otherwise we'll just append 0. And at the end of this actually needs to be a double integer, this is how you set up the matrix array. That was my bad. So yeah, this is the correct way. And at the end, we'll just append this temp row to the new matrix. Go outside here. And I think we can try running this to see how it goes. See how it looks. Okay, so this is what we have. And so you can see the border is all 1 and everything else is just a 0. So I guess this is like a representation of what our eye is going to look like. So all the zeros are probably going to be white, and otherwise it'll be 1. I mean, it'll be black. So I think that's what this code here does. So we're just checking if each position is either 0 or 1. So we can start that now. Create a new function. I guess to start, just set up another double for loop. And so first we'll start, we need like a base position, I guess. So we'll create a new button. Let's do this. So just be so we can keep track of them. So I think we'll do something similar. This is just so we can reference these buttons later on if we need to. Oops. So this is our basic code. So now we're going to actually set up So in the inner for loop, this is where we set up each individual button. So we create the UI button. And I guess the most important just if new matrix at this position. You get how indexing for matrices work? Do you know about it?
No.
No? Okay.
What do you mean?
So it's just it's like a XY coordinate, like math, where the first coordinate's your X and the second is your Y in a way. Except it's kind of like inverted, or just instead of you start here, you would start here. This is your 0, 0. So when you do new matrix, let's say, assume this is new matrix. If we did new matrix 0, comma 4, we would start at row 0, so here, and then we'd move to index 4, so 0, 1, 2, 3, 4. So this would be 0, 4. So similarly, we can do like 7. And we would just go to the 7th index, so 0, 1, 2, 3, 4, 5, 6, 7, and it will move along 10, or technically 11, including 0. So it would be somewhere here. Is that okay?
Yeah.
So that's why we do a double for loop, because then we can basically just construct row by row. It's pretty simple that way. You'll see later when we're building on. Okay, so we're just gonna check if at this coordinate the number is 0 or 1. So if it's 1, we'll set the background color to black. And otherwise, it's automatically 0, so we'll just do else. Give me a sec. I also want to do this. Oh, so this is a good. Oops. Oh, oops. Yeah, so this is kind of why we do an array to store our buttons, so we can just add them all with with 2 for loops. Otherwise, we could have also just added them directly in here. So we could just do B2. We just do this and it'll do each one. I like to keep my stuff separate though, so it's totally up to you. So uh, let's do it this way. Actually, let's keep it here. I'll comment this out. Here. Okay, back to this. Let's run this and see how it looks for now. Uh, mm, I don't have the frame. We need to set up the frame. That's the second most important part. Okay. For the frame, we need like a starting point. So I guess we can let it just start from the corner first. So to do this, let's do um we can just start 0. And so basically we need to increment each one based on their position. So let's assume each one has a width of 10 and a height of 10. That means if we start at 0, we need to start at 0 plus their width. So which we just know it's 10. So we can just do 10 times j. So that means for each one, we'll increase their position by 10. Hold on. 10 and then so like wait. Hold on. Yeah, we increase their position by 10, so it goes on to the next one, and then we multiply it. So like assume this is 10. So if we start at 0 and it's the first one, then this will be the first square. Then the next position's x starting point will be 0 times 0 plus 10 times 1. So that means it'll just start at 10, which is where the previous one ended. And then that one will end at 20. So then we'll go to the third box. And then that'll be 2 times 10 plus 0. So that'll be 20. So they just connect to each other per row. And so the y is also similar. So if we start at the 0, we also need to add vertically. So it's kind of the same formula. It'll just be 10 times j. Oh, wait, there should be 10 times I. Let's try this really quick. Hopefully I have that correct. Yeah. So we have something like that. And so we can also do this so you can just customize it on later on. We'll just define starting y and x. Just do like 30. Starting. So this way you can just modify the actual position of the box with these two values. Of course, you can modify the width and height. Then now the only other thing is we don't have a pupil. So to do that, we can treat this separately. I guess so once we have the eye built, we can create another function to build a pupil. So I guess for the pupil, we'll start with it being centered. And so let's see. This is another double for loop because we need to get the 2 dimensions. So let's set that up first. And let's make it 7 by 7 for now. So if that's the case, we'll just do that. And same thing, we'll create a temporary array here. Okay. We need a starting coordinate for where we want, like the very top left corner of the pupil to begin. So we'll create that again. Let's do just copy these. And we can actually just get the coordinates of the button this way, I believe. No, you can't. I mean, if we want to utilize math, we could, but I think it's easier right now. We just kind of wing it. Let's say we want it to start in the middle, then the x can be the we'll start at the middle, so it'll be, hold on, let's make it an integer. That'll be new matrix dot wait, matrix. We want to get the x coordinate, so that'll be like depending on the row. So that's where we get the first row of the matrix, and then we just get its length divided by 2. So that'll give us like the approximate middle. And for y, we can just do new matrix dot. And from there, we can just set okay. Okay, then we'll just do I plus star dx. Hold on. I don't think it matters. Let's see how this looks first. This one, we'll turn these black as well. And let's actually run build pupil before build I. So this will modify the number matrix, not the actual matrix. Oh, I messed up. That's fine. Let's see. It's probably just something wrong with the code here. Let's see what's wrong here. So we create the matrix. Let's build pupil here actually. We started at, wait, give me a sec, sorry. Oh, IJ. Wait, no, it doesn't sound right. Oh, this might be it. Let's see this really quickly. Okay, well, we have a square now, but yeah, so you can see it kind of represented here. I think something's still wrong though. Oh, let's do by 8. So then here we need to subtract half of 8. Sorry, I'm just testing stuff out. Test this really quick. Okay, it's pretty centered now. I think for here, we're going to add 4. Again, it's just a lot of experimentation with numbers, but this is a bit incorrect. Let's see. I should be the row. Oh, wait. Yeah. So we're going to build each row. That's why this is static here. Give me a second. I'm trying to see what's wrong here. Well, at least we have like the I, but starting. Hold on, let's see what he has. No. The pupil. Give me a sec. Uh, hmm. Okay, there we go. So I kind of messed stuff up, but now we subtract 4. There we go. So what I had missing was, yeah, I just needed this one here. And okay, so now we have the pupil set up. So that, I mean, I guess that looks like an eye, like a cartoon eye. And I'm gonna move this down a bit. And then now I guess we can start working on the logic for moving it. Um yeah, so let's do this. So let's make it so if they tap anywhere on the pupil, we'll check the location. And if it's on the left of the pupil, we'll move it slightly to the left. Otherwise, we'll move it to the otherwise, just depending on which direction they tap. In addition, if you tap on the pupil, nothing will happen because you're tapping on like its current location in a way. So let's start with that. Let's do here. And so let's do this. Yeah. So we'll do sender. And so we'll actually add a new thing here. When we build the eye and the pupil, or no, when we build the buttons themselves, what is it? Okay, so when we build the eye, we're gonna tag the button with the matrix coordinates. So basically us oh no, so basically a tag is like just an additional piece of info we can use. So we can like tag it one or and we can give it a number, and that basically is like a identification thing. So if I have like a button and it's like, so you'll see here. So we can do, you can access its tag, and now we can reference if it's like a specific number and do specific code for that. That in this case, if the tag is 1, that would mean the thing was black. So then it won't have an action. But if we have it equal to 0, then we can register it as a tap. And also in addition here, okay, so let's first run this. So see how all this works, but if I tap in the black, nothing happens. And so next, this is the big part. This is where I take a bit. We're gonna want to check if the position is outside of the eyes matrix. So let's see. Give me a sec. Eye buttons. I'm trying to figure out how I would do this. I guess we could. No, give me a sec. Uh, Okay, how about why don't we keep track of the eyes matrix coordinates? When we build the pupil, let's same thing we did earlier. Wrote up append. I should do this. Mhm. Oh, okay. We'll just append each coordinate. So I matrix dot append. We'll append its coordinates. So yes, starting y plus 1, starting. Okay. And now when we tap on this, let's check. Let's check first if center dot. Oh wait, that's tricky. We need to somehow get the position of this button here. Let's see. Give me a second. I need a. It's a bit difficult. Center dot. I guess we can check the coordinate. Origin. Is less than. Okay, let's go on X. Yeah, this is a bit strange. If it's less than, we need to get it to be less than the left side of the pupil. So instead of tracking integers, let's track actual positions. That means we would go into build eye and give me a second. This is a bit trickier than I thought. Now we'll keep this. I have the new matrix. Wait. Matrix. Uh, Okay, so that gives us, yeah, the exact coordinates. Uh, let's see. I guess we could assume. No, I don't like that. Let's see. I have another way. Instead of keeping track of each individual coordinate, we can split it up so it sorts in coordinates of x and coordinates of y. So let's do that instead. So here, x. Uh, append each row. Yeah, that should be fine. Let's try this. See how this looks first. Okay, so yeah, I mean that makes sense. We just don't have the y, but can we add the y? Let's see. Oh, this is tricky. I guess I could do this. So this you can chain arrays. So we're gonna try making a 2D array, and each one inside is its own coordinate. So we'll do this on matrix append row comma I matrix. Wait, hold on. Sorry. One more time. Let me see. This might be different. No. Okay. Give me one last try. Sorry, this is all over the place. Uh, where is it? Okay, so at each row, we'll append a new array here. So we'll do I comma, wait. I comma I plus, wait, starting with y. Okay, let's see how this looks really quick. No, oops. Okay, this sucks. Look at this. Right. Let's do this. Let's handle the left and right side logic. Untapped. Okay, so if in here we'll do sender.frame down max x is less than I matrix Okay. Oh, um, what was it? Okay. I see. Wait. Oh, hold on. This is. Hey, I'm gonna. Wait a second. Let's see. We need to. This is just math stuff at this point. Oh my god. If we top on the left, we need to find a better way to keep track of these buttons here. Let's see. Yeah, this isn't good enough. Let's see. Append. Yeah, I don't think we're finishing today. That's okay. Uh, that. This one. Okay. And this is close to what we were going for. So it's already 11, but I think we can continue from here. So yeah, I just had my code wrong, but basically we set up a 2D array and each element is another array. So that has like the exact coordinates of the pupils. That's what
Good.
this does. So next time, we'll just work on the logic here. So we'll be checking if the position tapped is less than or equal to the frames that are of these boxes here.
All right,
And
looks good. Yeah, Alex, does this make sense to you?
I don't, I need to explain more this. I rushed it
Yeah,
today.
I'm not sure about it.
All right, so
Uh,
could everyone open up your camera? Just well, see. Let's see each other a little bit quick. All right.
okay.
Yeah.
Mm,
Hey, Mark, can you open up your camera as well? And also show the exit code. Yeah. Oh, also need. All right, there we go. Good. Can Mark, can you open the X code again? Yeah. So overall, using a 2D array to handle the 2D objects is very important because eventually, all right, so computer itself is a binary machine, right? So computer understands binary better than people. So we use a binary code to create the backbone, and the front end is basically the UI rendering. And I saw Mark did the button UI button. That is a very good array. So Mark, could you please scroll up a little bit? Yeah. The not the console, the code itself. Yes, there we go. In line 15. Yes, that is very good. So we need a binary code array, and then we need a UI array to handle the work. So that is basically very important. Uh, so how do you better understand that? So the binary integer is like your bone, all right? You grow up, so you grow up your bone rate, and UI button is just like a skin and a muscle. So usually, all right, skin and muscle grow along with bone rate. So your bones get bigger first, and then the muscle and the skin, right? Makes sense, right? Yeah, usually it's that. I mean, that's the nature, that's the natural progress, right? Okay. So I guess whenever we're working on computer science, we always want to think in like a biological perspective, right? So it is simply because we create computer, and computer is supposed to be like human beings or like nature, right? All right, good. So I guess this is everything for today's, and let's see what is going on. Okay, so lots of progress today, and well, first we dive into the binary stuff, and then the UI, and then show the worlds like how it works. All right, great. Does anybody have any questions?
Oh, do you want me to send this to Alex?
Alex, do you need this to review?
Or we can,
Sure. I'll take a
yeah,
look at it. Yeah.
we'll finish it up next time. It's kind of incomplete right now.
Okay.
Yes. All right. Good. It
I'll
just
send it
well,
to you
maybe
after
put the
class. Yeah.
yeah, paste it at the Google Docs, so then it should be okay. All right. Good. Good, good, good. All right, there we go. So I guess this is it. I also upload some whiteboard stuff like matrix transformation stuff. That is good.
It's not really formatted.